Welcome to this video tutorial in balancing chemical equations. Before we go to the topic, I would like to think and for you to recognize the PowerPoint presentation that I used for this video came from the Currituck County Schools located in North Carolina, United States. Thank you very much. The topic that I included here is about balancing of equation. But before we deal with the topic, uh, I'll review you first with the essentials. First is again what is a chemical equation? Basically, it describes chemical change. It represents the overall chemical reaction that occurred. In all chemical equation, you'll be able to find the following. You have the reactant, which is the input of the reaction, and you have the product, which is the output of the reaction. You can also find an arrow, which represents the direction of the reaction. In this example, you have silver, which reacted with hydrogen sulfide to produce silver sulfide and hydrogen. An integral part of each chemical reactions or chemical equations are the subscripts and coefficients. Subscripts are the numbers that show the quantity of atoms of an element that are in a molecule. An example of which is water molecule. We have uh, 2 as our subscript. It denotes that we have 2 hydrogen atom, and if you cannot find any subscript, it only means that it is 1. So we have here 1 atom of oxygen. On the other hand, coefficients or coefficient represents how many molecules there are of a particular chemical. It is written before the molecule. You have here 3 as our coefficient, so it means that we have 3 water molecules. Next, so a chemical reaction is composed of uh, you have here again the reactants, and then you have the product. So we have a reaction of hydrogen which combined with oxygen to produce water. As you can see in this animation, we have 2 hydrogen molecules. Uh, it is represented in this chemical equation. You have 2 hydrogen molecules and then 1 oxygen molecule. Together, if they collided, they formed water molecules. So as you can see, we have formed 2 water molecules. Another observation in this chemical reaction, all of the molecules or the atoms were consumed during the reaction. So it means that uh, our reactants is always equal to the products, or simply say that the quantity of the reactants is always equal to the quantity of the products. So this was explained by Lavoisier when he discovered the law of conservation of mass. Let's go to another example. You have here an unbalanced equation. Let's look why this equation or chemical equation is unbalanced. You have here methane. It combined with oxygen to form carbon dioxide and water. As you can see, in methane, we have 4 hydrogen atoms denoted by the subscript and 2 oxygen atoms. So we have here 2 oxygen atoms. On the other hand, we have 2 oxygen atoms in carbon dioxide and 1 oxygen atom in the water molecule. On the other hand, we have 2 hydrogen in the water molecule and 1 carbon in our carbon dioxide. We have a problem here because our reactants are not equal to the products, because we have 4 hydrogen here and we can only find 2 hydrogen atoms in our product side. So what are we going to do? We need to balance them. So how are we going to balance this equation? Simple, by putting coefficients. So by adding another oxygen molecule and water molecule, so we simply put 2 as coefficient of oxygen molecule to simply denote that in this reaction, uh, there are in this complete reaction there are 2 oxygen molecules rather that were consumed, and after the reaction it produced 1 carbon dioxide and 2 water molecules. So this is balanced because, as you can see, the number of oxygen is equal, the same as the carbon and the hydrogen. We have 1 carbon on each side, 4 hydrogen atoms, and 4 oxygen atoms. Now we know that we need to balance the equation. Let's go to specific steps that you can follow in order for you to balance the given equation. So here are the rules of the game. First, matter cannot be created or destroyed. So it means that you cannot simply remove or add another element in the equation to make it balance. Next, subscripts cannot be added, removed, or changed. So let's have an example. So say for instance you have uh, water. Okay, I'll change the color. So you have water. So that water molecule, in that water molecule, you cannot simply add another subscript if you need to balance oxygen, because if you did that, this is another molecule. This is actually hydrogen peroxide. Next, you can only change coefficients. Next, coefficients can only go in front of chemical formula, never in the middle of the formula. So say for instance you wrote you have H2O, and then you need to balance oxygen, you multiply it by 2. You cannot do that, it's wrong. So here are other tips. So first, try balancing big formulas first and save free elements for last. Say for instance you have sodium or hydrogen molecule, oxygen molecule. These free elements are easy to balance because they call that there are no other atoms attached. Therefore, if they change in number, it will not affect another atom. Next, if the same polyatomic ions appear on both sides of the equation, it's usually okay to treat it as one unit. So say for instance, you have sodium hydroxide here. So it's our polyatomic ion hydroxide, and say for instance it formed aluminum hydroxide. So as you can see, we have 1 hydroxide ion here and 3 hydroxide ion in our product side. So you can treat them as one atom, because if you did that, it is easier to balance. But if it's only found in one side of the equation, it is another thing. Uh, I think the most important is that some equations are harder to balance than the others and might require some creativity to solve. But actually, in this tutorial, I'll be presenting to you 2 methods that you can use in order for your balancing experience to be easier. Let's go to the uh, specific example. So you have here sodium. It combined with chlorine molecule to produce sodium chloride. The 2 methods that I am going to teach you in this tutorial is the matrix method and the algebra. Oops, it happened. Algebra method. So for the matrix method, oh, what happened? For the matrix method, you'll uh, construct a table with two columns. On the algebra method, uh, you'll you'll be required to uh, represent the coefficients in variables. Let's have first the matrix method. So the first column will be for the reactant side, and the other one is the product side. And then you are required to list down the elements. So in case that there are polyatomic ions, such in the case our case previously, you can write the atoms as one. So you have hydroxide. Next, you're going to write the number. You're going to write the number. So sodium in our reactant is 1, chlorine is 2. In the product side, we have 1 sodium and 1 chlorine as well. So as you can see, this is unbalanced. How are we going to balance this? By changing the coefficient of what? So as you can see, chlorine is with sodium, and you can only write the coefficient before the molecule. So it means that the coefficient will be written before sodium chloride. So what are we going to multiply to 1 in order for it to make it 2? Okay, you're right. So it means that we are going to multiply 2 to sodium chloride. So this will be 2. Since chlorine is with a sodium, sodium will also be multiplied by 2. So this will become 2. Since the number of sodium is unbalanced, we need to balance, we need to change the coefficient in order for it to make it balanced. So we have here sodium, which is 1. As you can see, if the element is solo, no, it is easier to balance like this sodium. What are you going to multiply to 1 to make it 2? So you have 2. This will become. So you have that sodium is already balanced as well as chlorine. Next, let's have algebra. So in algebra, you have variables that represent the coefficient. So you have A, B, C. Whatever variable you want, it's fine. But in this case, we will be using A, B, C. Next thing is you are going to write the sodium and chlorine. Good thing about algebra is that you don't need to mind whether there are polyatomic ions present in both or absent or only present in one side of the equation, because in algebra you'll be able to compute the coefficients even though you break down the polyatomic ions. So we have here sodium. You can find it at variable A. So write A, and if you're going to go to the other side of the equation, write equal. It is found in C, and it is 1. Next, we have chlorine. Chlorine is found in variable B, and it is 2. So you have 2B. And then on the other side of the equation, it is found in C, which is only 1. So you have C. So say for instance, we chose this one. So you have 2B is equal to C. Just get the proportion. So 2 is equal to C. And I hope you know that if we have a variable, automatically it has an imaginary number, or there is 1 before that variable. So you have B is equal to 1. So list down the variables A, B, C. C is equal to 2 and B is equal to 1. Next, we are going to use the other formula. A is equal to C. Since C is equal to 2, therefore A is equal to 2. So as you can see, we balance the equation using the variables. You can use any of the formulas derived, but make sure that there are only two variables present. So we have A is equal to C. Therefore, we can use A is equal to C. The same process, get the proportions, ratios rather. So you have A is equal to 1, C is equal to 1. A, B, C equal to 1. So let's solve for B using the other equation. So you have 2B is equal to C. 2B, since 2B, C is equal to C rather, so this will become 2B is equal to 1. Let's simply divide both sides by 2. So you'll have B is equal to 1. In case you encounter fraction using algebra, just multiply the denominator of that fraction. In case there are multiple fractions present, just multiply the highest denominator. So in this case, we have 2. So multiply all by 2. 1 times 2, you have 2. 1 half times 2 equals to 1. And 1 times 2 is equal to 2. So you have the balance equation 2, 1, 2. Let's have another example. We have here aluminum combined with oxygen molecule to produce aluminum oxide. Let's use matrix. So we have matrix. We have matrix. We have the reactant, the product, actant. So we have aluminum and oxygen. In the reactant side, we have one aluminum, and then we have two oxygen in oxygen atom in an oxygen molecule. And then in the product side, we have two aluminum and then three oxygen atoms. In this case, both of the elements present are unbalanced. So which of the two are we going to choose first? Remember this, if we have a solo element like this aluminum, we are going to balance it last because whatever number we multiply to it, it is easier to balance compared to oxygen. So we are going to balance oxygen. Now we have 2 and 3. How are we going to balance that? By simply getting the LCM or least common multiple. So by this, we will be able to determine the common factor of 2 and 3. So you have 2, 3. So 2 is 2, 4. Oh my god, what's happening? You have 2, 4. Oh, that 2, 4, 6. While in 3 is 3, 3, 6, 3, 6, 9. So as you can see, our common factor here is 6. And in 2, in order for it to become 6, we are going to multiply it by how many? By 3. So it means that this oxygen molecule will be multiplied by 3. So 3 times 2, it will become 6. Next, on the other hand, 3 will be multiplied by 2 in order for it to become 6. So where are we going to write this? This part? No, you cannot do that. So we are going to multiply the whole aluminum oxide by 2. So it means that 2 times 3 become 6. Next, since 2 is with Since oxygen is with aluminum, therefore aluminum will also be multiplied by 2. So 2 times 2, it will become 4. But since aluminum is just 1, we can simply multiply 1 by 4. So you have 4 times 1 will be 4. So aluminum and oxygen is now balanced. Next, let's have the algebra. Let's have the variable A, B, C, and then list down all the elements: aluminum, oxygen. Where can we find aluminum? So we can find aluminum in A. Oh, in A. And then we can find aluminum on the other side of equation. So A is equal to how many? 2. So 2C. Next, oxygen is found in B. How many? 2B is equal to 3C. So say for instance, we pick the first equation. So A is equal to 2C. So simply get the ratio. So you have A, B, C. A is equal to 2, C is equal to 1. So we will solve for B using this equation. 2B is equal to 3C. Since C is equal to 1, we will multiply it by 1. So 3 times 1 equal to 2B is equal to 3. So we simplify this by dividing both sides by 2. So this will become B is equal to 3 over 2. Next, so what are we going to do if there's a fraction? Multiply it by the denominator. So you have 2 times 2 is equal to A is equal to 4, B is equal to 3 over 2 times 2 become 3, and C is equal to 2 times 1 will become 2. So you have that 4, 3, 2 is balanced. Let's have another example. You have here nitrogen molecule combined with hydrogen molecule to form ammonia. So as you can see, we have 2 atoms of nitrogen, 2 atoms of hydrogen in the reactant side, and 1 nitrogen and 3 hydrogen in the product side. Obviously, there is an imbalance. Let's have first the matrix method. Reactant, product. List down the elements: nitrogen, hydrogen. How many nitrogen atoms do we have in the reactant side? 2, and 2 for hydrogen. On the other hand, we have 1 nitrogen and 3 for hydrogen in the product side. So same as the previous example, we are going to get the LCM first of these two numbers. So the LCM of these two numbers is 6. So we multiply the two numbers that they will be able to have a product of 6. So for 3, we multiply it by 2. 2 times 3, it will become 6. But since it is with nitrogen, we also multiply nitrogen by 2. Next, and after that, we have hydrogen. In order for it to become 6, we multiply 2 by 3. So 3 times 2, it will become 6. So as you can see, in matrix method, take note that we write the product, not the coefficient. Let's have algebra. So we have the variables A, B, C. List down the elements: nitrogen, hydrogen. So nitrogen is found in A, which is composed of 2 atoms. And the other side, we have another nitrogen, which is only 1, so C. Next, hydrogen is 2, so 2B is equal to 3C. let's pick one. So say for instance, let's have the first one. We're going to get the ratio. So A is equal to 1, C is equal to 2. Then let's solve for B using this equation. 2B is equal to 3C. Since C is equal to 2, this will become 2B is equal to 3 times 2. 3 times 2. So 3 times 2, it will become 6, 2B. What are we going to do? Divide both sides by 2 to make B so low. So this will become 1, 2 divided by 2 is equal to 1. B is equal to 6 divided by 2, it will become 3. So you have 1, 3, 2. Therefore, this equation is now balanced. Now let's move to other examples that contain polyatomic ions. In this example, we have sodium phosphate. It reacted with hydrochloric acid to form phosphoric acid and sodium chloride. So as you can see here in our chemical equation, we have one polyatomic ion. This polyatomic ion is known as phosphate. As you can see, uh, it is easy to spot polyatomic ions because they are two elements that is together, no? Usually, if the compound is composed of three or more elements, the first element is a solo atom, and then the elements that follow is considered as polyatomic ion. Since phosphate is found in both sides of the equation, we can consider them as one variable. Let's have first the matrix method. There. You have the reactant side and the product side. Then you're going to list down the elements. But since phosphate is seen in both sides of the equation, we can write PO4 and then hydrogen and chlorine. Now, how will you know the number of our polyatomic ions? If they are not encased in parentheses, it simply means that polyatomic ion is 1. So in this case, we have a 1 in the reactant and 1 in the product. In case that they are encased in parentheses, the number that follows that parenthesis multiplies that polyatomic ion. So say for instance, we have uh, let's have wait let's have iron phosphate. So as you can see here, our phosphate is in the parentheses, and 2 follows the parentheses. Therefore, it means that this phosphate is 2. So in case that happens, you're going to write 2. Alright, next, sodium is 3 in the reactant, while 1 in the product. Hydrogen is 1, and then chlorine is 1. The hydrogen in the product side is 3, and the chlorine is 1. Uh, since the higher numbers are equal, we can choose one, any of the two. So say for instance, in the product side, we want to balance the sodium. We multiply 3 to sodium chloride. So this will become 3. But because chlorine is with sodium, it will also be multiplied by 3. Next, let's balance hydrogen. You multiply hydrochloric acid by 3, so hydrogen becomes 3. But since chlorine is with hydrogen, we also multiply it by 3. And we have the balanced equation. Now, let's have the algebra. Let's now put our variables A, B, C, and D. Okay, So, good thing about algebra is that you don't need to mind the polyatomic ions. You can write the elements in single. So, say for instance, we have sodium, phosphorus, oxygen, hydrogen, and chlorine. So we find sodium in A, it is 3, so 3A. You can see we have 3 sodium in A. Next, uh, it is found in the other side of equation, so equal to D. It's only 1. Next, phosphorus on the other hand is 1. There is no subscript. 1. So A is equal to C. Next, oxygen is 4A is equal to 4C. Next, hydrogen on the other hand, B is equal to 3C. And lastly, we have chlorine in B equal to T. Now, we are going to pick one. Say, for instance, we pick the first uh, formula. We'll get the ratio. So, A and then B. Write the variables A, B, C, D. A is equal to 1, B is equal to 3. Next, let's find B and C. In which terms can we find B and C? So, can we use this? A is equal to C? Of course, since we already have a value of A, we can find C. Since A is equal to 1 and C is equal to A, C is equal to A and A is equal to 1, therefore C is equal to 1. Next, for B, we can choose from these two formulas. B is equal to 3C or B is equal to D. I think this is the easier formula to use. Since D is equal to 3, therefore B is equal to 3. So you have the balanced equation 1, 3, 1, 3. Let's have another sample for this. Wait, it's not working. There. So in this example, we have lead hydroxide, then sulfuric acid, and then lead sulfate, and then we have water. So as you can see, we have two polyatomic ions here. We have the sulfate, and then we have the hydroxide. Here's the thing. If you found the hydroxide ion in one side of the equation, and then you have water in the other side of the equation, you can rearrange the formula. Rearrange the formula of water. So we will make it H hydroxide. So as you can see here, we just rearrange the formula for water. We have 2 hydrogen and 1 oxygen. We did not change the identity of the molecule itself, but we just provided a polyatomic ion so that hydroxide ions can be treated as one variable. It will only happen if we have hydroxide in one side of the equation and water in the other side of the equation. Let's use the matrix method. You have the reactants, the product, then you have lead, hydroxide ion, hydrogen, and then sulfate. How many lead atoms we have here? So we have 1 hydroxide, we have 4 hydrogen, we have 2 sulfate, we have 1. If you're still confused why sulfate is 1, we treat this as one variable. there. You will not base the number on the subscript because the subscript defines the number of oxygen. Next, in the product side, we have one lead sulfate. How many? So as you can see, there is a parenthesis, and outside the parenthesis, we have two. So it means that we have two sulfate ions. Hydrogen, on the other hand, we rearrange the formula already. How many? We have one, and hydroxide, we have one also. Since hydroxide ion has the higher number, we are going to approach this first. We multiply this by 4. So 4, multiply it by 4, water. So 4 times 1, 4 times 1, it will become 4. 4 times 1 equal to 4. Next, since hydroxide is with hydrogen, it will also be multiplied by 4. So this will become 4. Next, let's balance the hydrogen. We are going to multiply this by 2. So what will happen? Hydrogen will be multiplied by 2. So 2 times 2, this will become 4. And then sulfate, on the other hand, will also be multiplied by 2. So our sulfate will become 2. Is there another atom to be balanced? Is there other atoms to be balanced? So as you can see, every atoms or every parts of our equation are already balanced. So it means that this is already a balanced equation. Next, let's use algebra. You have the variable a, b, c, and d. Again, the good thing about algebra is that you don't need to have these fusses. You don't need to encounter those fusses. So you have lead, oxygen, hydrogen, sulfur. Those are the present element. Lead is found in A, and 1. A is equal to C. Next, oxygen. It is found in A. This multiplier, this subscript multiplies all the atoms inside the parentheses. So we have 4A. But since we can find another oxygen inside, in the same side of equation, so we will put plus. We will encounter this if we find another atom in the same side of the equation. Since we have two oxygens here, we'll have this equation 4A plus 4B. There. Why 4B? The subscript multiplies oxygen only. Next, we are going to the next side of the equation, equal to. So this 2 multiplies both of the sulfur and the oxygen. 2 times 4 is 8. So this will become 8 C plus, since we only have one oxygen in D, so write D. Next, hydrogen. So we have 4A plus, same side of equation, how many? 2B equal to, you don't have hydrogen in C, let's move to D, you have 2B. Last, sulfur we have in B, only 1, equal to, and we have in C, you multiply it by 2. So say for instance, we chose this equation. We cannot have this one because there are so many terms in it. Always choose the equation with only 2 unknown variables. A is equal to C. Get the ratio. So we have 1 here. A, B, C, D. A is equal to 1, C is equal to 1. Next, how are we going to find B? By using this equation, simple equation. B is equal to 2C. Let's write it. B is equal to 2C. Since C is equal to 1, uh, therefore, we multiply 2 by 1. B is equal to 2 times 1. So B is equal to 2. There you go. 2. Next, let's find D. Uh, so we have here an easier equation where we can find D. Let's rearrange it. 2D is equal to 4A plus 2B equal to 4 times 1 plus 2 times B 2 equal to 4 times 1 is 4 plus 4 equal to 2D equal to 4 plus 4 is 8. 2D. So we'll just simplify. Divide both sides by 2. We have D is equal to 4. So here we have the balance equation. 1, 2, 1, 4. Alright, so let's have a recap on the things that you have learned in this video tutorial. First, balancing equation, you cannot simply create or destroy or remove a compound or an element to balance it. And second, subscripts cannot be added, removed, or changed. Third, you can only change coefficients. And then coefficients can only go in front of chemical formulas, never in the middle of a formula. We have these tips: balancing big formulas first and save free elements for last, because they are easier to multiply in any number. If the polyatomic ion appears on both sides of the equation, it's usually okay to treat it as one unit. In case of the water, we just if hydroxide ion is present in one side of the equation and water molecule is present on the other side, you can simply rearrange these two hydroxide ion. In case that it, there is a hydroxide ion in one side of the equation. Next, some equations are harder to balance than others and might require some creativity to solve. So I'll be giving you a task to do. Try answering them, and then I'll be sending you a follow-up video later. Thank you.